given the coordinate of P are a comma b and the coordinate of Q are negative b comma a, such that a and b are constant, point P is in the first quadrant of the Cartesian plane with O as the origin. Okay, since point P is in the first quadrant of the Cartesian plane, so we know that the value of a and b are actually positive, right? Now let's look at this diagram. So point P is over here. So this is A unit, this is B unit. So A and B are positive number because point P is in the first quadrant. Okay. And the coordinate of Q is negative B, A. You will notice that the magnitude of OP and the magnitude of OQ, they are actually the same. If you, okay, why I say their magnitude are the same? Now, OP. The vector of OP is AI plus BJ, right? How about the magnitude of OQ? This is negative BI plus AJ. You will notice that these are different, right? But their magnitude are the same. Now, magnitude of OP is equal to A square plus B square root. So how about magnitude of OQ? Is equal to negative B square plus A square root whole thing, right? So negative B square is actually equal to B square. Now you can see that their magnitude are actually the same. OP and OQ having the same magnitude. Now the question asks us, state the range of value of k if the unit vector in the directions of OP is ki plus mj and given k is not equal to 0. Okay, now first try to think, how do we get the unit vector? OP is ai plus bj, right? To get the unit vector, we take the vector divided by the magnitude, right? So magnitude of OP is a square plus b square root this whole thing. Now, so the unit vector will be ai plus bj over this whole thing, a square plus b square. And given by the question, the unit vector is equal to this. This means that this is equal to this, right? Ki plus mj. Now let me change the way of writing this so that easier for you to compare both sides. So a divided by square root of a square plus b square. This is I. And b divided by square root of a square plus b square. Here is j. Is equal to ki plus mj. And the question is asking about the range of k. Now we only focus on this part. So k is equal to a over square root of a square plus b square. Now we want to state the range of k. So try to think, can the k be negative? It cannot be negative, right? Because a is positive, right? And this will not be negative. So we know that k definitely will be greater than 0 because it cannot be negative, right? Can it be 0? No, the question tells us that k is not equal to 0. Okay, if this is positive, these two are positive, actually you will not get 0 here. And try to think. Now this is a divided by square root of a square plus b square. So the number here actually will be larger compared with the number here, right? So that means when the numerator, this numerator, smaller than the denominator, we know that this is not going to be greater than 1. It's not going to be greater than 1. So I'm going to write less than 1. Can it be equal to 1? So if you look at the marking scheme given, I think this is a given answer. K is less than or equal to 1. But I think it's less than 1, not equal to 1. Why? Because try to think, when will the k equal to 1? Now k is equal to this, right? B squared. When the b is equal to 0, let's say when the b is equal to 0, then it will be a divided by square root of a squared, which is equal to a, then we will get 1. But can the b equal to 0? Because the question tells you that p is in the first quadrant, that means these two numbers must be positive. If the b is equal to 0, let's say some here, so the p will be here. I know the a, but the b, which is the y-coordinate of the point P, is equal to 0. This means that the point P is on the x-axis. So in this situation, we cannot say that point P is in the first quadrant. So in my opinion, the answer is k is greater than 0, less than 1. Cannot equal to 1. Okay, now let's look at part B. If the unit vector in the directions of 3OP is this, find the magnitude of 2OQ. Okay, now just now I told you that the magnitude of OP is actually the same as the magnitude of OQ, right? Okay, now we just need to multiply by 2 because this is magnitude of 2OQ. Now this is a unit vector of 3OP. Actually, the unit vector in the directions of 3OP and the unit vector in the directions of OP, they are the same. Okay, why? Now, let's say OP is equal to AI plus BJ, right? So the unit vector in the directions of OP is equal to OP divided by the magnitude of OP, right? So how about if we have 3OP, 3OP? So it will become 3AI plus 3BJ. So what is the unit vector? The unit vector will be equal to 3OP, the vector, divided by the magnitude of 3OP. And you will notice that this one, the magnitude of 3OP is actually the same as 3 times the magnitude of OP, right? So eventually, you simplify this 3, you will get still the same thing. Okay? Okay, so now, since this is the unit vectors of 3OP, it's actually the same as the unit vector of OP. So how do we get the unit vector? We know, right? OP divided by the magnitude of OP is equal to this. And can I change the way of writing this? This is OP. OP is AI plus BJ, right? And this is magnitude of OP. Now let me change the way of writing it. Become AI plus BJ and 2 over 5. Now by comparing both sides, you know that the magnitude of OP is actually 2 over 5. Now the question asks us to find the magnitude of 2OQ. Magnitude of 2OQ is equal to magnitude of 2 times magnitude of OQ. As I told just now, the magnitude of OQ and OP are the same. So what is the magnitude of OP? 2 over 5, right? And our answer will be 4 over 5. Okay, let's check the answer. Okay, correct.